Gravithon 2020 to Gravithon 2021 Think Test Capture. Today's session is going to be all about DevOps and cloud. First of all, I would like to wish you all a very happy Raksha Bandhan. I hope you all are safe and fine at home. So I'm sure you must have doubts related to DevOps and cloud. Let us get some insights from someone who has been there and has done it. Talking about today's guest speaker, he is a DevOps and cloud engineer at State Street Bank and Trust Company, Boston, USA. He has acquired rich experience in DevOps, automation, build engineering, configuration management, and is tactically and technically adept at management, AWS, ClearCase, Agile, Red Hat machines, and much more. He is none other than Mr. Mikhil Gangwani. I extend a very warm welcome to you, sir. Over to you, sir.
Thank you, Pranjal. Hi, everyone. Good morning, good evening, and afternoon, depending on the location you guys are in. Am I audible?
Sir, you're perfectly audible.
Okay. So thanks for inviting me. It's really a great pleasure to have you all as an audience. There is always a lot to learn from bright scholars like you. We all are here for Gravithon, which I was told has been organized by student of organization in lovely professional university. So many congratulations to you. I recall my days of college. I don't think we organize such kind of events in our time. So you guys are really talented. So keep working on these things. About myself, I work as an architect and my profile is focused on DevOps area and also mostly revolved around cloud space. Current role is as a release manager. So otherwise, I come from infrastructure background. In the past, I have worked on, like I started my career with Windows, Linux, VMware, and then I moved to management and monitoring tools. That was CA Technologies, which has been acquired by Broadcom now. And since 2015, I've been working in cloud space. And then gradually I was involved in all DevOps projects since 2016. So close to more than 12 years of experience I have. Today, I would like to cover mostly on basics of cloud computing and DevOps. So let's start. So I think let's start with what is cloud computing. So if I would like to put cloud computing in my words, then I would say making an arrangement, or probably any of the service provider making an arrangement for the users so that users can access a shared pool of configuring computing resources. Could be a network, storage, application, or any sort of service. And those resources should be provisioned and can be released. That means scaled up and scaled down, or scaled out and scaled in, as and when required, and more into automated fashion. Like there shouldn't be any manual interaction, like no human interaction. So that's about cloud computing. And I'll also cover DevOps. What does DevOps mean? And how CI/CD culture helps DevOps practice in day-to-day life. And what all are the frequent tools which we use in DevOps. So moving on, cloud computing. So I still recall in 2012, 2011, I was working on a private cloud without knowing that soon I'll start working on public cloud. So I was working on a project where we, as a team, we used to provide virtual machines, not just from VMware, but we used to create instances for HP, AIX, Linux, I mean, all of Unix flavors to developers and SQAs so that they can test their product according to their OS flavor. So how we used to do, so we had our own data center that was on premise, and what sort of services my company was providing, it was all monitoring and management tools. I'm sure you might have heard about computer associate technologies. So like internal, so we were, client was our internal teammates, like CA technology employees itself. So we, from our data center, we used to create a shared resource of pool. We used to lease them those resources. If someone is working on a product which has to be enhanced on Linux, so he used to ask us Linux machine with 1 CPU and then 2 GB RAM and probably 100 GB hard disk. So we used to create it from the VMware and then lease it to him or her for 3 months and then send a reminder like, okay, your 3 months are over. So things were not as automated as they are now in 2021. Yeah, thanks to cloud computing. Moving on, what it provides. So since you do not have to take care of infrastructure, and there could be a service model which I'll cover in upcoming slides. There could be a PaaS, like platform as a service or software as a service. There you do not have to worry about underlying operating system or underlying application. Then developer can actually focus on development, doesn't have to worry about the background infrastructure. Then their productivity will increase, their speed will increase, they'll be more agile, and their efficiency will definitely increase. And then access information. So since cloud can be accessible from anywhere, any part of the world, for an example, Amazon Web Services, you can create a word but in US location. So cloud computing is, you just need one laptop and internet access, that's all. And since you do not have to acquire resources, then you save cost there. Moving on to their characteristics. So again, as I mentioned, I'll cover service models later, but in one of the model, this multi-tenancy and resource pooling fit there. So how it fits there, if you are not a government company, or if you are not complying with all the governance law, then you can share the resources. When I say share the resources, if let's say if there is a NetApp storage of like multi terabytes or like more than that, and if you need it, then what cloud provider or what the service provider will do, it will give it to multiple consumers. What consumers will do, they will access it, but they don't care who all are accessing it. They can like storage can be dynamically assigned and reassigned according to their needs. But at the same time, they are aware about the risk because it is in a sharing mode. Moving on to elasticity. As I mentioned, in 2012, we used to, I'm sure in 2012, others probably like Amazon, because that's the one of the leader in cloud market. So probably they were still doing things automatically, but I myself was doing manually. If someone was asking about the, initially they asked for one CPU, but they are not able to do the development with one CPU, then they used to raise a request in the system. And then I used to increase the CPU as per their need. But now, thanks to cloud, it can be extended within seconds and can be released as well, right? Resources can be released as well. And provider's intervention is not required. So doing this is really a quick thing and very responsive. Like, I'm sure you might, if you are in third year or fourth year, you might have heard about, like, they have their SLAs, service level agreements. They are very strict about their SLAs. If anything goes down, then they have like availability, which is one of the another feature of cloud computing. Like they might have some 99.95% SLAs. So there also you are covered. And measured services is another characteristics of cloud computing. When I say measured service, it's like pay per use. Earlier in 2000, what we used to do, we used to acquire the entire server, and you have to pay out of your pocket for the entire server. Doesn't matter if you're going to use for the entire year or entire server or not, but you will still pay for it. But in cloud, you just pay. If it is one CPU, then you'll pay only for one CPU. If it is 4 GB RAM, then you only pay for 4 GB RAM. Moving on. So it's a on-demand self-service. So when I say self-service, Azure person will not come and provision it for you. You yourself can provision any of the resources as per your need, but you just need to take the subscription for them. And it's all like self-service. It's on. So they say it's on demand. Moving on to service models. This is what I was discussing in my earlier slides. Like, there are service models. To start with IaaS, it's infrastructure as a service. So when I say infrastructure as a service, before explaining, I will take an example. I'm sure all of you are aware about on-premise. So when I say on-premise, so let's take an example. On-premise is our own car. If it is like, or probably, or your own bike. And IaaS is like a leasing car. You lease it for 3 years and then you return it. PaaS, that is platform as a service. So that could be a taxi, like a cab. Like, you pay for it from your source to destination, you're done. And software as a service, it's like a bus or train. You're paying for the service. You don't care, like it is taking you from one destination to another destination at a certain point of time. So to explain about infrastructure as a service, service provider will give you storage, like their hardware, the, the networking component. They'll give it to you. You need to take care of doing the installation, like operating system installation. Virtualization also comes into your bucket. You need to maintain the applications, but you do not have to spend on the infrastructure. So that's infrastructure as service. So what are the providers? Rackspace, DigitalOcean, GCP, Google Cloud Platform, and then Microsoft Azure, and then we have Amazon Web Services. That's the leader currently. Moving on to platform as a service. So platform as a service will outsource the basic infrastructure and platform. So when I say platform, let me move to another slide and then I'll explain it. So do you see these models? I mentioned like on-premise, all the blocks in green color are being managed by us in on-premises. And then in infrastructure as a service, all the green color are again managed by us. And the orange color blocks, like virtualization. When I mentioned PaaS, let me go back to the previous slide. When I mentioned about the platform as a service, then they are taking care of networking, storage, servers, and virtualization for us. We are only doing the operating system, and we are configuring runtime, and then we are taking care of application. Going back to software as a service. Before that, let me take an example of platform as a service. So platform as a service is Salesforce, or I'm really not sure if you guys have heard about OpenShift or Elastic Beanstalk. That's one of the AWS service. Moving on to software as a service. Software as a service is like, or I'll take another example. Let's say if pizza is being delivered to you, you don't care what sort of dough they used and what sort of ingredients they use. They just deliver it to you. So it's like a software as a service for you. Is my screen still visible?
Yes, sir, it's properly visible.
Okay, thank you.
Service models are visible.
Okay, thank you so much. So moving on to software as a service. So everything is being taken care by service provider, like networking, storage, like entire infrastructure, platform, and application as well. So you do not have to worry about anything related to infrastructure. But at the same time, they come with their, like, if they're providing you these many services, they come with some cons as well. Like there are some disadvantages, but at the same time, cloud companies are taking over those disadvantages. So example of software as a service will be WhatsApp, or for the argument's sake, Zoom, which we are using today, or I would say email, or Google Docs, Dropbox. So they are an example of software as a service. Moving on to DevOps. Before that, let me also cover about the disadvantages. So disadvantages could be security. That's the main concern of any organization. Like everyone is afraid about, like, if with all the speed, efficiency, and innovation that comes with cloud computing, there could be risk. So for an example, compliance issues, or these days, many organizations are going with multi-cloud culture. Like they don't want to be dependent on one cloud. They'll go with Amazon and Azure and Google Cloud altogether because they don't need vendor lock-in. So that's one of the disadvantage, because they have to manage all the clouds. So when I say they have to manage all the cloud, so just think about, they need expertise, like employees who should be who should have hands-on on all three cloud providers, like Amazon and Azure and then Google. So that's one of the disadvantage. And then second will be, when you are on premise, they have to do migration, right? That's called cloud migration. Like they, if there is, let's say, one of the server which is outdated and you need to migrate it. So they need some sort of expertise there if you want to save some money. I'm sure a cloud provider can do migration for you, but they'll charge you a lot there. So that's one of them. And if it is infrastructure as a service, let me go to previous slide. So if it is a infrastructure as a service, then it's a pay as you go model. Like you only pay for the resources which you use, and you have the complete control over your infrastructure. You can scale it, you can downsize it as you need, but the pain of buying the physical server goes away. So that's one of the advantage for IaaS, infrastructure as a service. For platform as a service, one advantage will be, developers can actually customize their apps. They do not have to. I still recall developers doing operating system installation before even starting their development, so they don't have to worry about it. So it's uh, it's another advantage. But and software as a service, you don't have to worry about upgrading your application itself. You don't have to worry about upgrading like software. Like these days, even WhatsApp has releases probably every 2 months or every 1 month. Same like Zoom. So these releases, earlier, developer was doing the upgrade himself or herself. So now they don't have to worry about it. But one of the disadvantage will be, SaaS tool might not be compatible with the hardware that is already in use by the business. So we are at the mercy of SaaS company and their security features. All right, so moving on, DevOps. And my screen shows as DevOps, right, Pranjal?
Yes, sir, it's visible.
Okay, thank you. So what is DevOps? To start with, DevOps is I would say it's a culture. I work in agile rooms, so I'll give you background of it. Like we work on stories, and then like there are like product owners, there are scrum masters, and SQAs. So all are in one room, and then we work on stories. So DevOps is also, so we follow DevOps as well. So what does it mean is, Dev means development team and ops means operation team. They work together and they try to aim at better collaboration and perfect communication. So when I say better collaboration, what if developer will make an update to an existing application and doesn't care about how does it look like in production? Then operation team need, so entire pain will be on operation team, right? But in DevOps culture, DevOps, they'll work together and then they'll leverage many tools from project planning until it has been delivered. So CI/CD also part of it, continuous integration and continuous development or continuous delivery, I would say. Moving on to terminologies which we use. First will be infrastructure as code. So when I say infrastructure as code, that means you are managing or probably you are provisioning. I'll start with an example, an EC2 instance, not manually, not like a physical hardware configuration. You are doing it with machine readable definition files. And let me give you an example there. So I'm working on Terraform. That's one of the infrastructure as code technology. So in Terraform, you write your code there and Elastic IP will be configured for you. I mean, you do not have to go to AWS dashboard to configure it. You can do it from Terraform. So that's infrastructure as code. And there are many more services there, like CloudFormation is also infrastructure as code. SaltStack is another infrastructure as code service. And then we have Docker. Docker is one of the buzzword today. So when I say buzzword, earlier we used to work on monolithic application, but now everything has been containerized. Developer can develop their application in a container, and operation team will take care of collaboration and orchestrate that Docker with the help of Kubernetes. So I'll cover Kubernetes in a minute. Before that, Ansible. Ansible is also open source. So Docker is also open source and Kubernetes is also open source. So Ansible is an open source software solution, which is agentless. Like you do not have to install any of the agent and you do not need any of the programming. You don't need to know any of the programming language. Like you don't need to know coding. So in YAML, you can simply write YAML. It's very simple. And it's a very, as if it is simple, at the same time, it is very powerful tool. So what it does is it automates difficult and time consuming processes and converts them into playbooks, which really helps in increasing your productivity. Moving on to Kubernetes. So it actually manages the container. It orchestrates your containers. It necessarily doesn't need to be Docker. It can be any container technology. So one of the most powerful tool, I would say, Kubernetes. So and it is leader as well. There are many more. Docker Swarm is also there. So there are many more, but I personally like Kubernetes. Moving on to other DevOps tool. So I'll start with the planning. So that's if my cursor is visible, if not, but then look at the center of the tool, that is Jira. So in Jira, I personally have not used Jira, to be honest, but we are using RTC, that is similar to Rational Tool Clear Case. So we are using that one, that's from IBM. So Jira is a tool which where you can do planning. So why I was giving you a background of my work, we are working in Agile. So how it works is we do a planning session before the development. We work like 15 days in one of the Agile room, and then we deliver it. And then next 15 days, we work on another feature. So that's how we do it. So in Jira, you do the planning, like product owner will write stories in that planning session, and Scrum Master will assign those stories to developers, and SQA will also pick it up for their testing. So Jira is one of the tools where you can do planning. And then moving on to Git or Eclipse. So in Git, earlier, developer used to check in their code in their own workstation. Like they used to do the development at their own workstation. There was no central repository, but Git is a central repository now. So multiple developers can check in their own feature branches, and then everything can be merged either by developer itself or by DevOps person. So once code has been checked in, then with the help of Maven, Radle, and Ant is also there, we can do the build. We can bundle it. We can bundle the code. And while we are doing the bundling, developer and SQA, they can come together and they can do the unit testing with the help of Cucumber, JUnit. These are the tools which we use currently for the unit testing. And regression testing tools are different, but they use it for now for their testing. And then comes Jenkins. It's a configuration integration tool. So once the bundle has been done, then they'll create a jar or a zip file with the help of Jenkins, and then they'll deploy it with the help of these tools mentioned here. We use Docker in our environment, and then operations team will take it from there. Like they'll use all monitoring tools, other management tools. We're using Splunk, but not Nagios. With the help of Splunk, they can monitor if production is not working as expected. So that's the entire circle, how the development and operation works. Moving on to this slide, I just put for the sake of comparison, or just to give you more idea about what tool does what. So purpose of Ansible is cloud provisioning and application deployment. So with the help of Ansible, you can actually automate complex IT functions and also automate software configuration management like continuous deployments. And with the help of Puppet and Chef, you can do configuration management. I personally like Puppet because it's very simple to install. Like no extra plugin is required, as it is not required in Ansible as well. And uh, just so you know, NASA and Capital One Bank, they're using Ansible. And just to give you more examples there, Jenkins is being used by LinkedIn and Capgemini company. So Jenkins is a continuous integration process. Like you have to integrate it and do the build, right? So Jenkins comes into picture there. And Docker, it's a container technology. So it is really a fast technology, I would say, goes with any platform. Like earlier, developer used to say, or I'm not blaming developer, but that was his job. He used to do the development, and they used to say, okay, it was working in my machine. If it is not working in your machine, then it's not his issue, because he was given a window machine and it was working in Windows. But now, thanks to Docker, you can package your application in any platform you want and then do the testing. There is no blame game now. So moving on to, let's talk about Ansible, Kubernetes, and Docker more. So as I mentioned, Ansible is used for automating repetitive tasks and the complex IT functions like rolling updates. You can really do the rolling update as fast as you want. It enables you doing faster application deployment. And Docker, I already covered about it, like it's a container technology, and you can build, run, and ship your applications. It's a very lightweight, like it's not, you can take it to any platform you want. And Kubernetes, it actually works or orchestrate the containerized applications. It uses like nodes, like a master. I mean, we have a master node as well. We have worker nodes. So it uses those nodes to handle the scheduling and other management activities. Moving on to comparison between Docker and Kubernetes. So just to mention, I'm actually not comparing it. I'm just telling you the features. When I say features, Docker can work without the Kubernetes, and Kubernetes can also work without a Docker. It's just that if they both come along, they actually become a powerful culture. So Docker doesn't come with auto scaling, like it is not the actual feature, but Kubernetes has an auto scaling feature. Installation in today's world, fast moving technology, I would not say it is very difficult, but yes, it is difficult setting up multi-master node when it comes to Kubernetes. But Docker, it is very easy to install, and load balancing can be configured in Kubernetes manually, but in Docker, we cannot. I mean, we can, but Kubernetes is more powerful than Docker. And Kubernetes has built-in logging and monitoring tool. Docker does not offer it. In Kubernetes, we can optimize various small clusters and large as well. But Docker is only designed for one single cluster. Customization, it has more customization in Kubernetes, relatively less customization in Docker. Shared data volume, we can share data volume with any container with the help of PVC, persistent volume claim, and persistent volume. But in Docker, it only shares data volume with the container, which is in single port. So moving on to more features about Ansible, Docker, and Kubernetes. Ansible, as I mentioned, it's agentless and it's very simple. So most of things have been covered here. So it's a very powerful tool. And I will reiterate myself, you do not need to know any of the language if you really want to start your career in DevOps. So, and you are not good at programming, then Ansible is the right choice for you. Like it's very easy to learn. And then Docker, it has really a good integration skills. Like it can integrate with Docker Swarm, Kubernetes. So, and all of Ansible, Docker, and Kubernetes, all of are open source. And Docker is, as I mentioned, it's very lightweight. You because there is no hypervisor, or there is no like extra uh, virtualization layer there. And Kubernetes, it's if you don't know, it is backed by Google. So initially it was a product which was designed by Google, and now it has given to the open source community, but originally it has been backed by Google. And it's one of the most powerful and leading Docker, or probably containerization management solution. Moving on to, so as I mentioned, I was not comparing it. In DevOps, we are focusing on writing scalable and distributed application, which can run anywhere, anytime we want, in an automated fashion and more efficiently. So how Docker helps, how Kubernetes really be a leader there. So with the help of Docker, developer can provide the first step. That's run our software any platform and ship it anywhere we want. Kubernetes can help in orchestrating the container, and then with the help of Ansible, you can automate your deployments. So as I mentioned in my last line, is it really Docker versus Kubernetes versus Ansible? No, it is Docker and Kubernetes and Ansible. If they come along, then you really do not have to worry about your development and deployment. Moving on to continuous integration and continuous delivery. So if you know that earlier, like traditional culture, probably 20 or 15 years back, how developer used to do, they used to develop their code, and they used to build their code in an isolation, and at the end of the project they used to integrate it. So what used to happen was either integration was failing, or they were finding like multiple bugs, or so client was asking something and end product was something else. So now what happens is developer will integrate their new code into a shared repository, which can be anything, maybe Git. So they'll check in their code, and they can check in multiple times a day, because everything has been automated now. So they can do multiple deployments a day, which we do in our current environment, be it database deployment, be it Java deployment. So it can be of any technology. So as I mentioned, it's really fast. Productivity increases, and that's a continuous integration. And continuous delivery will be we are automating the build and deployment features. Like as soon as code will be checked into GitHub, so it should trigger a build, and it should bundle your code, and it should deploy to servers, be it cloud, be it non-cloud. When I say non-cloud, it can be your on-premise Linux server, or it can be on-premise Windows server, and it can be on cloud as well. And also with the help of Kubernetes, you can do the deployments. So that's the continuous delivery. And then you have very limited bugs, and it is as fast as you want. So this is from the slide which I was discussing. You do the planning, and then you do the coding, and then everything gets built up. And at the same time, uh, you can do all sort of testing, and then you can release your product in UAT environment. So that's in continuous delivery. This is what I was saying, like continuous delivery is automating everything. So everything should be automated. You should not spend much time in deploying new enhanced features. So once it has been released in lower environments, that can be UAT, then once it has been tested, it should get deployed to higher environments. Could be BUAT, that's business environment, or can be to production. And once it has been deployed to production, then then operation team can take it over, and they can check the unusual behavior of production. Moving on to benefits. Now, developer is only focusing on writing the code, doesn't have to take care of anything else, like doesn't need to concentrate on installing operating system or anything else. So productivity increases. So it's more agile now. And then QA, when I say QA, there is like testing team and product stakeholders, like product owners or end client. They have fast access to the latest code. Earlier, when we were working waterfall model, after a certain point of time only, business stakeholders were checking, like they were able to see the end product. But now, as soon as one agile room is done, you are able to access the latest feature, and then the desired product and end product are same, like with very less bugs. And uh, since this build and deployment has been automated, then logs for all the code changes and all the builds and deployments, they are available at a shared repository, which can be integrated with Jenkins. And also you're using Sonar there for code quality. And if something goes wrong, again, rolling back is also a push button approach. If a version of application V1 was deployed to V2, like from V1 to V2, then V2 to V1 is as easy as it was V1 to V2, because it is automated. And stakeholders can give you a feedback, like, okay, this is not working, can we do another deployment? Since deployment is automated, it's just that developer needs to make the changes, and very next day, or probably it's the same day, those features will be available in lower environment. And once it is tested, we can move it to next, like BUAT environment. These releases are not as stressful as they were earlier. So that's all I have about DevOps and cloud computing. I am open to any questions or any comments or any feedback.
Thank you so much, sir, for this informational session. I personally learned a lot of this because as a second year student, I was thinking to go about in this field and I got a lot of insights. Thank you so much, sir. We have some questions who are from all the students, and some of them are, what is the best cloud platform? Google Cloud, AWS, or Azure?
Okay, so that depends on a personal perception. I started my career in cloud as AWS, with AWS. But okay, so I do not have more experience in GCP. I have in Azure as well, in Oracle Cloud as well. But at the same time, Azure is more, if you really want to. So again, I'm not making a statement here. I'm just giving you my personal perception. AWS is easy to learn, but if you really want to get your hands dirty, then Azure should be your option, because because it's it's little difficult, but at the same time you get more insight about the cloud.
Okay,
So that's my personal perception.
thank you, sir. So the next question is, what are the daily life uses of cases of Docker?
You can develop your applications there, like in containers. So how it used to work earlier, let me go to my previous slide. So earlier we were working, let's say, take an example of on-premise, we were taking care of everything, like from procuring infrastructure, doing configuring virtualization, installing operating system, everything, right? But now you just have to install or configure your applications in a container, which is not in this slide, but you just have to configure your application in a container and you're ready to go. You do not have to do the blame game, like it is not working in Windows or it is not working in HP flavor. For any OS flavor, containers are available.
Okay, so I got the point. So this is my personal question. Can we get a job as a fresher in DevOps and cloud? And what will be the package of this job?
Yeah, that's a very tricky question, but yes, you can. I also started as a fresher, but I don't think DevOps was there when I started. But at the same time, when I can start a job as a fresher, anyone can start. At the same time, about the package, that depends on the company or organizations which you are joining. Who will so Microsoft can give you as more. I mean, it again, it's a tricky question. It depends on the organization and about the uh, project or about the role which they are hiring you for.
Okay, so we have one question in Q&A box. What are the best resources for learning the DevOps and cloud?
Get hands on. Don't just read the slides. Don't just read the documentation. There are white papers. There are like other things as well. But while you're reading it, get hands on. Don't just I would say don't just go for uh, learning. But so for an example, uh, just learn try to learn things, but try to deploy those learnings somewhere. I know
Okay.
one of the student, he is Likhit's friend. He's Abhishek Sharma. He's just passed out. He knows him, I think. So that's how I invited in this conference. So he has really done wonders with his learning. Try to uh, like I would say uh, apply your learning somewhere. Do some POCs. When I say POCs, not the actual POCs, like proof of concept. Go and I would say go and uh, create your own application. So that's how, and I'm sure, and I challenge you, if you apply your learning somewhere, if you create a live product, no one can stop you getting as much package as you want. And that answers your question, like definitely you'll get your job.
Okay, so there is one more question. If we want to get our hands on, we need to get some internship and something like that. So where can we
No,
get in?
no,
Oh,
you don't have to. You don't have to. The person which I am giving an example, he was not an intern. Now he's an intern, but he was not an intern. He was spending all his time on his own project. Ideas, anyone can give you, or probably there are many ideas, like, can you create uh, an application which will monitor share market for me? Or can you, I mean, there are like many ideas. I can add you guys, or I can give you uh, a group or communities link, which can help you, or which can really uh, leverage you for uh, doing the POCs. They are not doing it for any company, just to be clear. They are just doing for the purpose of learning. That's all.
Yes, so that will be a great help. So the next question is, what kind of certifications are required for DevOps and cloud?
As I mentioned, certification is not the key. Learning, and I mean, certifications could be required as per the demand of that role. But at the same time, if you're doing the certification, do it from your heart. Like, don't just do it for the sake of doing it.
Exactly. So that is it. Thank you so much for your time and for taking your time from your busy schedule. And I wish you all the very best.
Yeah, thank you, Pranjal. Thanks everyone for inviting me. It is really a great pleasure to meet you all. I wish you, or probably I wish all the students a great success. And thank you, everyone.
Thank you so much, sir.
Thank you, sir. Thank you, sir, for coming to the Gravithon 2021 and made this event successful. Thanks a lot, sir.
I would also like to thank the audience for attending this session. Stay tuned with us for more such sessions. Till then, this is your host Pranjal Bhalla officially signing off.